Welcome to Lesson 3.5, Interpreting the Discriminant. The solutions of a quadratic equation determined using the quadratic formula illustrate that the value of the radicand in the formula determines whether a quadratic will have 2, 1, or no real roots. For the quadratic equation, ax squared plus bx plus c equals 0, the roots are given by x equals negative b plus or minus the square root b squared minus 4ac divided by 2a. The expression b squared minus 4ac is called the discriminant of the quadratic equation, and it has 2 real roots when b squared minus 4ac is greater than 0, exactly 1 real root when b squared minus 4ac equals 0, and no real roots when b squared minus 4ac is less than 0. We can see that this is true because b squared minus 4ac is inside the square root in the formula. And so when it is greater than 0, we have a possible situation of 2 real roots. But when it equals 0, it's going to go away and we're only going to have 1 real root. And when it's less than 0, we'll have no real roots because we cannot square root a negative. So let's look at this. Without solving, determine whether the equation 9x squared minus 6x plus 1 equals 0 has 1, 2, or no real roots. So to determine if the equation has 1, 2, or no real roots, we use the discriminant b squared minus 4ac. And in this case, we have an a of 9, b of negative 6, and a c of 1. So let's plug that in. We get negative 6 squared minus 4 times 9 times 1, which equals 36 minus 36, which becomes 0. So since our discriminant of b squared minus 4ac equals 0, we can say that this equation has 1 real root. Let's look at a different example. Example 2. Creating an equation with a given number of roots. Part A asks us to determine the value of k for which the equation 2x squared plus 7x plus k equals 0 has no real roots. So for no real roots, we want our discriminant of b squared minus 4ac to be less than 0, right? So let's plug in the values we are given for a, b, and c and check to see what value of k this is true. So we have a equals 2, b equals 7, and c equals k. Then we get 7 squared minus 4 times 2 times k is less than 0, right? Simplifying, we get 49 minus 8k is less than 0. Isolating k, we get 49 is less than 8k, dividing by 8. We have 49 divided by 8 is less than k. So for this equation to have no real roots, we need our k to be greater than 49 divided by 8, which is approximately 6.125. Part B asks, use one value of k to write an equation that has no real roots. So in part A, we found out that for k greater than 49 over 8, which is 6.125, the equation has no real roots. So let's choose a value, say k equals 10, which is much greater than 6.125. So now our equation 2x squared plus 7x plus k equaling 0, we can plug in for k and we have 2x squared plus 7x plus 10 equals 0. And this is an equation which should have no real roots. Example 3. A number is subtracted from its square. Can the difference be negative? Justify your response. So first of all, we need to let, say, x be the number. So the square of the number looks like this. And since a number is subtracted from its square, we say x squared minus x. We want to know if the difference can equal a negative. So let's let, say, y represent the difference here. So then we get x squared minus x equals y. Let's rewrite this as x squared minus x minus y equals 0. So we want to know if a solution exists. We want either one real root or two real roots. So in this case, we want our discriminant, b squared minus 4ac, to be greater than or equal to 0, including both possible situations. Let's go ahead and plug in for a, b, and c. We get negative 1 squared minus 4 times 1 times negative y is greater or equal to 0. We get 1 plus 4y is greater or equal to 0. So 4y is greater or equal to negative 1, and y is greater or equal to negative 1/4. So this shows that there are solutions for when y is greater or equal to negative 1/4. So our difference of x squared minus x can equal a negative for values of y between negative 1/4 and 0.